Hello everybody, Beaton here and welcome back to another past paper practice video. In this video I will be tackling some questions on circle theorem. So let's head straight into this question. So the question says, in the diagram above not drawn to scale, O is the center of the circle, angle AOB is equal to 130 degrees, angle DAE is equal to 30 degrees, and AEC and BED are chords of the circle. The first question says, calculate the size of each of the following angles, given reasons for each step of your answers. So the first thing we want to do is calculate the size of angle ACB. So ACB would be this angle here. So I want to calculate the size of this angle. So let's see. I have ACB and I also have AOB at the center of the circle. So I see AOB is 130. AOB is 130. And AOB is the angle at the center. And if you look at the two end letters, A and B, so we have one angle at the center or one angle at the circumference. They have the same two end letters, the same two end points. So that means we can use the theorem that says the angle at the center is twice the angle at the circumference. So you can say AOB is equal to, since this is 130 and this is twice of whatever is here, so in order to find this angle, we need to divide the 130 by 2, which will give me 130 divided by 2 will give me 65 degrees. So ACB is equal to 65, and the reason would be the angle at the center is twice the angle at the circumference. So here it would be 65 degrees. So next one says CBD. So CBD would be this angle here. CBD would be that angle. So we have CBD, and also let's see what our angle we have. We have CAD. So we have CAD being equal to 30 degrees. It's nice to write out the names of the angles. So CAD is this angle here. That is equal to 30, and we want to find CBE. If you look at the two end letters, once again, they are the same. But in this case, we have two angles on the circumference. So we can say CBD is equal to 30 as well because of these two end letters. And if you look at it, if you try to isolate it, we'll have, let me lose another color. We have, I'll isolate it. We have here, and we have this angle here. So we have these two angles, and we can say we know the theorem that says angles in the same segment are equal. So angles in the same segment are equal, so here is equal to 30 degrees, as easy as that. So it's nice to label. When you label, you can see the theorem clearer. So the next one says we want to find angle AED. So AED would be here. So AED would be this angle here. So I want to find this angle. So here's the thing. I already have this angle, and I already have this angle here. If I use another color and I draw here, I would say I will have a triangle. So what I can do, I can find for this angle here. So I can say, before I find ADE, I can say, let's call this angle here X. So I can say X is equal to 180 subtract 30 plus 65. So this will be 180 subtract 30 plus 65 would give me 95. So 180 subtract 95, 85 degrees. So if I know here is 85, the reason for this would be the sum of angles in a triangle is 180. And then I can say, if here is 85, and I have these two lines intersecting, and I have this angle being opposite to that angle, I can say angle AED will also be equal to 85. And my reason would be vertically opposite angles are equal. So vertically opposite angles are equal. So here would be 85 degrees, as easy as that. And with that, this has brought me to the end of this video in which I tackled these circle theorem questions. So one thing you want to do, you want to label label the angles. Label the angles, they will help you to determine which theorem to use and which theorem is applicable. And you know some of the main theorems, so just label it and that will help you. So with that, this has brought me to the end of this video, and I'll see you in the next video in which I'll be tackling some more questions. Until then, take care and keep practicing.